Inside of this ice core is trapped the environment from about 50,000 years ago. One of the things you can easily see in this ice core are small bubbles. That's the atmosphere trapped at the time that this particular ice was formed.
Scientists have only been deciphering the pages of these frozen books for about 40 years. Geoscientist Jim White unlocks their secrets at the Institute of Arctic and Alpine Research in Boulder, Colorado.
We can crush it up, we can remove the air that's inside of here and find out how much CO2 is in the atmosphere, or how much methane or other greenhouse gases were in the atmosphere at that time that this ice core was formed. So this ice core is a wonderful book, if you will, a recorder of the past environment.
He says this old ice can bring new understanding about global warming.
So it's not just that the past tells us what happened, but the past gives us some clues about what could occur in the future. One of the neat things about ice cores is that in areas where you have lots of snow accumulating every year, you have very detailed time records. Greenland is a place that has lots of accumulation. So we can look at year-by-year changes 20,000, 30,000, 40,000 years ago.
White's recent analysis of Greenland ice cores, a National Science Foundation-supported project, has revealed some important clues about rapid climate changes near the end of the last ice age about 11,700 years ago. At the time, there was a 22-degree Fahrenheit temperature spike in just 50 years in the Northern Hemisphere. When you're talking about major changes to the Earth's temperature, 50 years is practically the blink of an eye. The triggers for those ancient, dramatic climate changes: atmospheric circulation, like the jet stream, ocean circulation, like the Gulf Stream, and fluctuations in levels of sea ice.
Where are those trigger points in the modern climate system? Is it sea ice, which is disappearing rapidly? Is it ocean circulation? Is it atmospheric circulation? Or is it some combination of those three? I would say we're still flying blind when it comes to whether or not a rapid change is on its way.
More and more data from ice cores is expected to improve computer models for predicting future climate change. That's vital, said White, so the planet can be prepared to adapt.
Greenland contains something in the neighborhood of 20 feet of sea level rise, where the entire Greenland ice sheet to melt, that would inundate, drown major cities like Miami and Houston and New Orleans, Oakland. It would be, all around the world. So it's important to recognize how much ice is up there.
There's a certain rugged and spirited nature to the scientists who work in temperatures around -20 Fahrenheit. This time-lapse video is from the drilling shelter at the West Antarctic Ice Sheet Project. After the cores are drilled and retrieved, they are painstakingly prepared for study at more than 24 universities, with an occasional break for some calisthenics in the cold. Ice cores from the Antarctic and Greenland are flown to the National Ice Core Lab, a National Science Foundation facility near Denver. Many then make it to White's lab at the University of Colorado.
We measure about 10,000 samples a year, so we have to take some fairly detailed records in this ice core. There's a thermometer that lurks within the ice. This one is based on the ratio of heavy hydrogen to light hydrogen. The more heavy hydrogen you have, the warmer the cloud was that made the snow.
Like all those crime scene investigators on TV, these experts determine the what, where, and when, but with evidence from eons ago.
This is a system that will analyze carbon monoxide concentration and isotopes in ice cores.
Well, this instrument here is measuring the hydrogen isotopes of methane. And what that tells us about is where the methane comes from. Is this coming from the tropics? Is it coming from polar regions? The evolution of the ice core analysis has really been remarkable over the last 40 years or so. As we say, every time we measure an ice core, we find new information.
Information that could make a difference in our planet's future. For Science Nation, I'm Bruce Burkhardt.